Hi, my name is Atman Singh, and I'm the head mentor of 17456 Atlantis. This is the first in a line of SolidWorks tutorials that will teach First Tech Challenge teams how to utilize the CAD software SolidWorks to create a digital model of the robot before the manufacturing and fabrication processes begin. This is useful because when you're building, you could run into errors regarding space, but in SolidWorks, you can work out all of these errors so you can see if any collisions happen, and you can quickly just delete the part and then rework it. The second thing you can do with SolidWorks is create custom parts, given you have access to a CNC router or a 3D printer. So if I open up SolidWorks right here, you'll see we have a welcome page with a couple of tabs. So we have a recent document tabs, which shows all the files that you left off last time you closed SolidWorks. So I have a little robot that I'm working for a CAD challenge. And then we have a tab called New, which shows you a part, an assembly, and a drawing option. So a part is a file where you how the name implies, you create a part. So for example, maybe a plate for your drivetrain or an intake wheel or something. And then once you have all of your parts ready, you can import them into an assembly file. And then here is where you connect your parts together. And you, for example, your entire robot or your intake subsystem or your elevator subsystem, it's all stored into an assembly file, which stores a bunch of part files. And then we have a drawing file, which I've heard that the engineering notebook will be changing this year, but in before years, teams like to use this feature in order to show like it shows a sheet of paper and then a bunch of angles of your parts and assemblies, and that just gives the judges a level of understanding of like how your parts and assemblies look from all angles, as well as it shows a more professional look in an engineering notebook. So we're just going to click on part, and it's going to take some time to load. We're going to have, yeah, right there. So the first thing we'll be doing is we're going to click on the front plane in this left tab right here. This is called the feature tree. And then we're going to hold down shift and click on the right plane. And this will select all of our planes right here. Now a plane is what is basically the groundwork for what our part will, what part we're trying to make. So once we have these all selected, we're going to right click our selection right here and click on this little eyeball that says show. So now you can permanently see all your planes, and this makes it a lot easier to work with your CAD model. So how to control SolidWorks, you're going to need a mouse. You can't really do this on a trackpad or else it's going to be really annoying. So I recommend that you get a mouse if you don't have one. But to rotate around, to orbit like this, we use the middle mouse button by holding that down and then just moving our mouse around. And then to like pan the display, we can hold down control and then hold the middle mouse button down and then move the mouse. To zoom in and out, you can use the middle mouse button by scrolling up and scrolling down. So if we scroll up here, it'll zoom out, and if we scroll down here, it'll zoom in. And then like I said before, you can orbit with the middle mouse button, and then if you hit control, you can pan. So we're going to start a sketch on the top plane. So how we do this is, as you can see, we have our tabs right here. I'm going to get into this later once we get into the more technical stuff. But we're going to click on sketch, and then we're going to make like a little rectangle here. So we're going to select center rectangle, and then we're going to choose which plane we're going to sketch on. I'm going to do this on the top plane, and then we're going to find, as you can see, our cursor locks to the center of the plane. We're going to find the center of the plane, click on it, and then drag outwards. So now we have our rectangle right here. So and then another thing you can do with sketches is say we want this side right here and this side to be equal. What we're going to do is we're going to select our two sides by selecting our first one, holding down control, and selecting the other one, and then we're going to click this equal sign right here. As you can see, there's a tab right here called Add Relations. Horizontal basically just makes one of your selections and the other selection on the same horizontal plane. Vertical does the same thing, but vertically. Collinear lines up your two selections perfectly. Perpendicular lines them up perpendicularly. Same for parallel. Equal, like we just showed, sets the two measurements of the selections equally. And then fixes the object in place. So now that we have this, we have a square right here. we can click on this tab right here that's called Smart Dimension. This is what we use to tell SolidWorks how big we want, or how long or how wide we want our shape to be. So we're going to select this side, we're going to click, and then we have something right here where we can input how long we want it. So I'm going to set it at 4 inches. Since I'm working on IPS, I can just enter 4 and then it'll autocorrect to 4 inches. And yeah, now we have our 4-inch square. So to make this a 4-inch cube, we're going to go to Features and then click Extruded Boss / Base. Once we select this, we have a preview of what we're about to do, and then a tab right here which you can use to manipulate your boss extrude. So this is the distance right here, which displays how much you're extruding your sketch. So since we want it to be a perfect cube, we're going to enter 4 because that's how big the sketch is. And then once we have that right here, we're going to click check. And there, we have our cube. So now we're going to do like some aesthetic stuff. We have something up here called fillet. What fillet does is it takes a sharp edge and it makes it rounded. So if we select all 4 of these edges, as you can see in this preview, it rounds out this edge. And over here, we can tell the radius of how much or the severity of how much you're rounding the edge. So if I go more up, it'll be a lot more severe of a fillet. And if we go more down, it'll get closer to that perfectly sharp edge. But we're gonna set it at 0.2. Oh, oops, 0.2, and we're gonna click check, and there we have some rounded edges. And then as you can see over at the fillet tab, we have a little arrow right here. If we click this arrow, we have this button that says chamfer. What chamfer does is it kind of slices down an edge. So I can't really describe it, but I'll show it right here. So say we want to chamfer 0.1 inches. Yeah, so this fillet rounded the edge completely, but this chamfer kind of chopped off like a triangle from it. And then if we want, we can fillet down this chamfer to make it just even more round if we want to. Yeah, so we have this weird looking cube right here. So what we can also do is we can slice parts out of an object. So if we go to Features and then click on Extruded Cut, we're going to select a plane that we want to go through. So say we want to create a hole in the top of the cube. We're going to select that plane on top of the cube. We're going to select Circle over in our Sketch tab. We're going to find the center, pull it out, and then over here we can select how large we want the radius to be. So we'll make this a 1-inch radius circle. And then once that's ready, you can click Extruded Cut. Again, you can click Extruded Cut. And then, yeah, you can click check mark. Or if you want to change how much it cuts, so say you only want it to go halfway through, you can set this to 2 inches. But I want it to go all the way through, so we'll click 4 inches. And we'll click check. And yeah, we have a hole in our cube. So yeah, this is basically the extent of what we're going to do with this part. Okay, now that we've made our cube, we're going to utilize this in an assembly. So before doing that, we're going to hold down Control and S, and that'll save this thing. And we're going to name it cube. I have a folder right here where all my files are here. So I'm going to create a subfolder, SolidWorks. I'm bad at typing. SolidWorks tutorials. And then what I like to do is I like to create a folder for parts. That's a capital A, whatever. And a folder for assemblies. And obviously this is a part we're going to store in parts. We're going to click save. And there, we can utilize this. Okay, so now that we've saved it, we're going to click on this file tab. And then we're going to click new. And here is the tab we saw earlier with all the assembly and the drawing. We're going to click on assembly. We're going to click OK. And this is going to create a new assembly. And automatically it's going to bring up this tab right here, which is what we're going to use to import parts into it. So we're going to click on this cube right here. This is the same file we just created. And we're just going to drop it down by clicking it. and the orbiting and everything is the same in assemblies as it is in parts. So we have our part right here. Say we want another part. We're going to go to assembly. We're going to insert components, and since we haven't made a second one, we only have one component. We're just going to drop a secondary one of this cube right here. Okay, so we have our two cubes. If we try to move this right here by clicking on it and then moving your mouse, as you can see, it says the selected component is fixed. It cannot be moved. And this is because it's fixed in space. However, if we click on this and move our mouse, it moves just fine. Why is that? It's because the first part you import into an assembly is automatically fixed in space. If we right click this, we can see there's an option called float. If we select float, we can all of a sudden we're able to move it just fine. But we're gonna keep this fixed so that our assembly doesn't move at all. And then if we click a floating object, we can click fix. But I'd advise you don't really fix objects in space, because the point of SolidWorks is to create a one for one or as close you can get to it recreation of the robot you want to build. And if you're just fixing stuff in open space, that's not really accurate to what you're going to be doing, and you're going to come up with errors. So say we want to connect these two objects. We're going to take this face and then bind it to this face. And how we do this is through a process called mating. We're going to click this tab right here called mate, and there's a little paper clip. And then we can click coincident here. So here are the separate kind of mates that you can use in SolidWorks. The coincident mate takes a face and another face, and it connects them together. The parallel mate takes a face and another face, or a line and another line, and it aligns them parallelly. Is that a word? I don't know. And perpendicular mate does the same thing as the parallel mate, but perpendicularly. And then the tangent mate takes a circular object and mates it to a face. And then a concentric mate takes one hole and another hole and aligns them up. So we're just going to start with coincident first. Say I want this face to be connected to this face. We're just going to select these two, and then we have a check mark box right here. I'm going to click OK, and there. So if we go out of this mate selection place, we can still move this object, but I cannot at all move this below the other cube. It stays, these faces stay mated together until you either delete that mate or an error comes up. So while that's a way to mate things, there's a better way to mate things that's a lot faster. So say we want to line these two holes up. We're going to click one of the holes, hold down Control, and select the other. When we release Control, as you can see, the entire mating, or most of the mating menu from before is right here. So it's a lot faster to do as opposed to clicking on the mate tab and then selecting your two faces, blah, 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 blah. So say we want to concentric mate them, I'm going to click concentric, and bam. So now the only thing left to do is to align these faces parallelly. Again, I don't know if that's a word, but we're going to click this face, click the other face, release, parallel. There. So now if we try to move this cube, the selected component is fully defined, it cannot be moved. So we have our assembly, whatever this is, a stack of boxes, I guess, and it's completely done, it's fixed in place.